The moon has no atmosphere. Okay, I need to be a little bit careful. If you actually go and you Google, does the moon have an atmosphere, you may find a webpage on NASA talking about the moon's atmosphere. However, although technically there is some gas around the moon, specifically more than what we find in between the planets, it is so thin that it would be considered a good vacuum on the Earth. Now, a vacuum is a region of space with no matter in it. So something that would be considered a vacuum on the Earth, I would consider no atmosphere. So for the intents and purposes of this class, the moon has no atmosphere. And that is because its escape velocity is so low. Escape velocity, if you remember back, is how fast something has to travel to actually escape. So the escape velocity is low, meaning that even slow-moving things are going to be able to leave the moon. And because of this, it has not been able to hold on to any atmosphere. Now, because there is no atmosphere, there's no atmospheric pressure, which means there can be no liquid water. Part of the reason why the Earth has liquid water is because of the pressure from the atmosphere. Remember, whether something's a solid, liquid, or gas is determined not just by temperature, but also by pressure. And for water, if there's no pressure, it can be a gas or it can be a solid, but it cannot stay as a liquid. It has to have a little bit of pressure to remain in that liquid stage. So because there's no atmosphere and no atmospheric pressure, there can be no liquid water on the moon. Now, also because there's no atmosphere, this means that the sky is going to be black. Remember back, the reason why our sky is blue is because of the scattering of light within our atmosphere. If there's no atmosphere, there's no light scatter, so there's no blue sky. Here is our second lecture quiz question. A surface with a lot of craters is A, young, B, old, or C, there's no way to tell its age. Go ahead and think about it and we'll discuss in just a bit. Alright, what do you think? A surface with a lot of craters is B, old. We say that it's old because it's had no processes to renew the surface, to cover up those craters. As we look at the moon, we see three different types of terrain. We have the light regions. These are referred to as the highlands, sometimes called the terra. We have the dark-colored regions. These are known as the maria. And then on both, we have lots and lots of impact craters. The dark regions, the maria, were actually originally believed to be oceans. As people were first considering the properties of the moon and how it might be, they saw that the dark area was different than the lighter area and figured that maybe these are seas or oceans. In fact, that's where the term maria comes from. Now, we actually know today that there can be no liquid water on the moon, therefore these cannot actually be seas or oceans. Instead, we believe they are ancient lava flows. However, the moon, as far as we can tell, has been geologically dead for pretty much its entire existence, which means that these are lava flows, but they are not actually volcanic. They did not erupt from a volcano. Instead, what we believe happened is that the surface of the moon got hit really hard so that it actually cracked the surface, which then allowed lava to flow out and fill in low-lying regions. So it is a lava rock, but it's not actually from a volcano. Now, as far as we can tell, the maria are actually younger than the highlands. We can tell this because of crater counting. There are craters on the maria, but there are fewer craters. And because there are fewer craters, that means that the surface must be younger. About 85% of the moon's surface are actually the lunar highlands. Here we have an image of both the near side of the moon and the far side of the moon. So the near side is the one that's always facing towards the Earth. The far side is the side that's always facing away. When we look at the near side, we kind of get a feel that maybe the moon is about 50-50 maria and highlands. However, when we look at the backside, that's absolutely not the case. The backside has very few maria. Now, based off of crater counting, we can tell that the highlands have to be much older than the maria. They have way more craters. So one question we have is, why does the near side have more maria than the far side? Our best guess is that the far side had a thicker crust, and because the crust was thicker, it was harder to actually crack to allow lava to flow through. Another interesting feature of the far side is that it has the largest impact basin in the solar system. An impact basin is kind of like a giant crater. Something really big hit. This actually carved almost all the way down into the mantle. Now, the moon has been geologically inactive for pretty much all of its existence. We see absolutely no evidence of volcanoes and no evidence of tectonics. Here is our third lecture quiz question. All rocks on the moon are igneous. Which is a reasonable explanation? A. The moon has no processes to make sedimentary or metamorphic rock. B. It was recently superheated and cooled. Or C. Our surveyors are most sensitive to igneous rocks. Go ahead and think about it, and we'll discuss in just a bit. So why do we only see igneous rocks on the moon? The answer is A. The moon has no way to make sedimentary or metamorphic rock. Sedimentary rock is formed as smaller rocks are broken down and then compacted and glued back together. Metamorphic rock is caused by tectonics and volcanism. Well, the moon has no atmosphere, so it has no weathering and erosion, so that means we can't form sedimentary rock. And the moon does not have tectonics or volcanism, which is what we need to make metamorphic rock. So the correct answer is A. The rocks that we find in the Maria are very similar to a type of lava rock we find on the Earth called basalt. Basalt is what makes up most of the ocean floor. Basalt has a relatively high iron content, which suggests that the moon actually differentiated. Remember, differentiation is this process of separating based off of densities. Higher density things sink down, and lower density things float out. The highlands are made of a type of rock called anorthosite. This is a light rock, light both in color as well as in density. This also indicates that the moon likely differentiated since the crust was primarily anorthosite. We have found a few pockets of anorthosite on the Earth, only in the very oldest mountains, and we believe that it was likely the Earth's original crust. Similarly, we believe that this anorthosite is the moon's original crust. A third type of rock we find on the moon is impact breccia. Impact breccia is actually rock formed from impacts. The idea is that meteorite impacts will break up rock, and then if you have a really big one, it will heat the rock, causing it to melt and fuse back together. So it actually kind of looks like a sedimentary rock in that it's made up of a whole bunch of smaller pieces, but because it melted and then cooled, it is still considered an igneous rock. Now, we mentioned previously that the moon has no atmosphere and therefore has no weathering. However, there is a fine layer of very powdery soil referred to as regolith, which has been formed through billions of years of micrometeorite impacts. A micrometeorite is a meteorite, but it's relatively small. So think like grains of sand. So the moon has been sandblasted for billions of years, creating this very fine powdery soil, this regolith. Based off of breccia and other rocks on the moon, we can see that the solar system went through a period known as the period of heavy bombardment relatively early on. So in this graph, up and down, we're looking at the rate of impacts in time. So 4.5 billion years ago is right when the solar system formed, and during that time, because of accretion, we expect lots and lots of impacts. And then the impacts began to decrease. Then they increased again about 4 billion years ago, and then they have decreased to a much slower rate. This period where we get the spike is the period of heavy bombardment. Based off of current evidence, we actually believe that the period of heavy bombardment was caused as Jupiter migrated. It actually shifted a little bit in its position, which disrupted the asteroid belt, causing more things to fall into the inner solar system than normal.